The year is 1800, and I want to introduce you to this little guy called the peppered moth. Light in colour, little bit of speckling, hence name peppered. Also meant to have legs and antennae and stuff, but I cut those off. 1800. 50 years later, 1848, for the first time, a new form of the moth is observed. These are still part of the same species, they still mate with one another, but this one has a genetic mutation that causes it to be darker in colour. Now, 50 years later, again, end of the 19th century, from being a tiny proportion of moths, one study finds that a staggering 98% of the moths they observe are this new dark colour. Now, what's going on here? What's caused this rapid spread of this new trait? Is it evolution in action? Now, evolution requires three things. Number one, variation. We have that. Number two, what's called heritability. It means that the genes that code for the dark colour are passed down to the little baby moths. And third of all, it requires what's called differential survival. Now, this means we need to look for a mechanism by which the dark-coloured moths are more likely to stick around for a long time and have lots more little baby moths. And a solution to this was first proposed in 1896. Now, imagine you're a bird flying through the forest and you're looking for lunch. It's a nice healthy forest, lots of lichen on the bark. Now, which of these moths are you more likely to spot? It's a dark-coloured one, right? But now, imagine that humanity has discovered the wonders of fossil fuels. The Victorians are busy revolutionising industry all over the place, and they're pumping out lots of pollutants, all the lichen dies, and the trees get covered with soot. And so now, which of these are you more likely to spot? It's the light one, isn't it? The dark one is now better camouflaged. And the theory goes that this rapid switch in the environment causes a consequent rapid switch in the population of moths. And experimental evidence for this came 50 years later when this brilliant guy called Bernard Kettlewell, in this extraordinary series of experiments, marauding through the woods with crazy nets of all times of day and night, he found actual experimental evidence that in a polluted wood, a dark moth is less likely to be eaten by a bird than a light moth. And that ought to be the end of the story, right? But I have to add this little coda, because unfortunately, in recent years, the dark forces of irrationality, aka the creationist lobby, have got hold of this story, and they've begun to try and undermine it, and to spread the impression that it's been debunked. But I am here to tell you that that is not. And in fact, the only new evidence for this came out in a study in just 2007, completely vindicated Kettlewell's original findings. So I'm here to tell you, stand by the story of the peppered moth. Viva la peppered moth! Because it is, in a very real sense, a graphic illustration of evolution in action.